let's see, sounds good. Great. So this is delivering flexible design systems. And so as a quick sort of warning, at the beginning, there are a lot of moving images and flashing images in this talk, i.e. there are a lot of GIFs. So if you're at all sensitive to that, maybe step out. If not, I think it should be some fun. So with that out of the way, hi, how's it going? I'm Charlie. I like to think of myself as some sort of fighting lobster on the internet, but I am a senior director of engineering at GoDaddy. You can find me on the internet pretty easily. I'm also on the board of the OpenJS Foundation, which was formerly the Node Foundation. I've been doing Node, I guess, now for about 10 years, so 10 years of Node.js experience, check. So you see that there, UX platform. You probably have a face that sort of looks like this. What is it? What does it mean? So I'll just sort of jump in pretty quickly. We have a lot of engineers at GoDaddy. So there are about 500 engineers that use the front-end tooling that my team builds. And they need a way to navigate it, to think about it, and to serve a consistent experience to customers. So another way to think about it is that it's the cross-cutting user interface technology. It's just a little bit more than the design system, so it includes things like shared wayfinding. If you use something like Gmail or Google Docs, it's something very similar. There's a header that lives at the top. We have something very similar. So let's talk about the design system. It's called UX Core 2, and it's about 50 or so React components. It's React-based, obviously. It's been going for almost 4 years now. It has a lot of contributors from throughout GoDaddy. That was something we focused on very, very early, was getting the rest of the product engineering group to make contributions to it. So if you find a bug in the dropdown, that shouldn't be our job. That should be the engineers on the product team's job. So what does this mean? Obviously, it's a lot of like broad generalization. So let's break down the problem. We are delivering flexible design systems, and the word choice there is very, very intentional. So let's talk about what design systems are. There are a bunch of different elements of a good design system. Who here has heard of atomic design? So think there's an opportunity for this metaphor to be below atomic design, right? You have atoms, but inside of atoms there are neutrons and protons and those sorts of things. So they never really talk about this in that metaphor, but I think it's really important. Like your color palette, for example, that's not really an atom, that's a subatomic thing. Your typography spacing, those sorts of things. The voice that you want to use in your technical writing. And then on top of that, you have just a ton of components. Just lots and lots of components. And in the atomic design metaphor, these are, of course, the atoms and molecules. And then something that often gets overlooked in design systems is documentation. So you'll see something like this, and then it gets turned into something like that. So you really need living documentation that gets kept up to date for all of your disciplines, not just for the engineers. So by that I mean the designers and the technical writers and just other contributors out there, like, for example, product management. So that's what this site that I showed earlier is. It's the entire documentation site for all of the components. Consider even something like a button component that's like super simple, very obvious. We've all used buttons before. There's some developer documentation that looks like this, but then there's some very detailed designer documentation that looks like this, like when do I use this color button? What does it mean in the broader system? And I like to fall back to sort of a principle or philosophical idea that I learned in grad school many years ago, which is that intuitive equals familiar. So anything people talk about design or things like that, oh, it's intuitive. Often the most intuitive thing is just what you've seen before. And the same goes for developers and developer workflows. The workflows being really, really important. How do you ship a change to your product? How do you make sure that when you make a change in the design system, that product gets updated? They don't have to do a lot of work. And lastly, there's a bunch of really boring things, especially at a big company, around governance. So if you've had product managers compete over what feature is right, you sort of know where I'm going with this. And anytime somebody comes in and they say, hey, I've got this great feature that I want to ship into the system, you have to say, well, is that really necessary in the system, or is that just something that your product needs to do, and you should do that separately from the system? So that's design systems. Let's talk a little bit about flexibility. So first off, we've all doing responsive design, right? That's just like not an option anymore. Great. I'm just bringing that one up. But now when you think about flexibility, it's not just flexibility on a single platform, it's flexibility across multiple platforms. So this is an example of our dropdown. We can see here on web, it's sort of working like you would expect it to work on native. And the really interesting thing about this is that when we started building the native dropdown, we just decided that this was a better experience on mobile web. So we backported the design from React Native to web, because it was just better. Similarly, when you start to think about features in desktop, certain teams in certain desktop scenarios don't want this behavior. They still want a traditional dropdown, and that's okay, but there are only certain use cases for it, and unfortunately, like this on the right here is possible. It shouldn't happen, because when they switch over when they see their viewport is smaller than desktop, they should turn off that prop, but they don't always do that, so we have to catch and look for that. So you're going to get asked to make a lot of features. And how many features is too many? I can't tell you that, but you're going to get a lot of feature requests. The next one that might have you sort of doing this throughout building things is styles. I think that's a very common thing that's discussed today is, should you have CSS? Should you have inline styles? What about if you need both? There are plenty of scenarios where inline styles are better, or actual proper class names and separate CSS files are better, and it really isn't a one-size-fits-all solution. Lastly, are you really a single brand? So when you think about design systems, about the embodiment of a single brand, at GoDaddy we're dozens of brands. So there's dark colors. This is, you might be familiar with Media Temple, maybe not. Some people are. This is a German company called Domain Factory. And there are just dozens and dozens of these choices. So we also have like 17,000 reseller customers that they can choose their own color palette. So we support, I think it's something like 700 different brand variations in the system. And that has a lot of implications for the types of things we have to do versus you're building out, say, I don't know, Vodafone's design system or a single brand's design system. You can make very poignant and flexible choices. For example, the Lambda Calculus of color selection. So going back to our example earlier with our buttons. So buttons are given a design prop. So we say, hey, I want a button. Its design is primary or its design is secondary. And originally, this was designed to map to the color choices on the SAS you can see on the left there. But what happens when a brand wants to map their quote-unquote primary button to a secondary palette color or a different palette color? This is just pure Lambda calculus. But people don't think about this that way. They think about it as, oh, it's just SAS, it's just styles, we can get out of the way. So just a small call out of some of the really nuanced things you can see when you're supporting lots and lots of different brands. So let's get to the meat of our content here, which is that we're going to talk about delivering. And of course, not pizzas. We're talking about delivering software, which for me anyway, I end up feeling like this most of the time. But there are some very distinct phases of this. You're going to develop. You're going to publish your package. You're going to promote that through one or more environments. You're eventually going to hit production. And then once you're in production, you have to maintain that software. So I'm going to go through these sort of in order for a little while, talk about different facets of them. So when you're developing, of course, you're furiously typing on your keyboard. And this is where the workflow really is king. And it's important to remember that these workflows are shared across your team. I don't know how big your teams are, 5 people, 10 people, 20 people. But these things that you're doing need to be really easy for you to do with other people. So when you get these new contributors, you need to think about how is it going to be easy for them. Like, okay, this is easy for me because I've done it 100 times, but what if you've never done this before? What if you don't know where the any key is? So you one of the philosophies that has been helpful for me to make this work is that if you treat every entry point as though it could be a first interaction, that you've never seen something before, then you can usually catch most of these edge cases and fix them before they're big problems. Typically in JavaScript land, this means small modules, so shrinking things down, making them small and understandable, because these are easy to understand. Each of the components in our design system are individual NPM packages, they're individual Git repositories, because when you find that bug in, say, a button or a dropdown, you need to say, oh, this is the smallest piece of code that I need to understand to fix that bug. This is, I think, against the trend today, which is that most people take all of their tiny little modules and they turn them into a monorepo of some sorts. And I'm not opposed to monorepos. They're certainly useful in a lot of scenarios, but they require a lot of diligence. So if you go into any of the really large monorepo projects that are out there in open source land, a lot of them don't even have a good README for all of their packages. And so when you do npm home that package, there's just nothing. There's just a blank page. The package JSON doesn't know where to go. So you're just like, I don't know where this code lives or where it came from, so it's just not useful anymore. Of course, there are many other tools in the development process that you may or may not be using. When it comes to preview and those sorts of things, I would highly recommend using something like Storybook. Seriously, it just works really well. I've been very impressed with it. Their native support in Storybook 5 has also been very significantly improved. But Storybook isn't always enough. There are a lot of sort of boilerplate bits of code that can get repeated over and over again. So having some kind of example structure really helps make that easier. So what do I mean by an example structure? So this is very simple, basic Storybook usage. We have a button. We're going to write some stories. But this is all designed to live in a single file. And now you imagine that with like 25 or 50 examples. It becomes very untenable very, very quickly. People don't know where to find the example they're looking for. It's difficult to navigate. So how can we do something that's better? There is some pretty simple boilerplate that a lot of people use in their Storybook, which is to load some things that are called stories.js files. But these, similar to having your test files and your code files live side by side, can be pretty confusing. But it starts to get the right kind of example. That this example is copy and paste ready. I can say, hey, here's an example, go take this, put this in your code, and it just works. So you want it to be as simple as possible with a bunch of different things. Clear import usage, platform-specific examples, design documentation. There are some other things out there that are doing this, like DocZ, if you've seen it. It's solving similar challenges. But Storybook continues to have that really versatile, almost Leatherman-like set of features, which is that it's development-focused, it is more flexible, but it's not quite a full solution. So what would help augment it? Consider this structure. You have something that is your examples. So you have anything that runs cross-platform, anything inside of a web directory can actually be only run on web, similarly for native. Then, of course, you need something to alias, right? If you've ever looked at a bunch of stories, let's see if I can go back and see here. So you'll notice here that the import is relative, right? That import ... components button, that's relative, and that's a problem, because what's the real package name for that? I don't know. So that's why you need some kind of aliasing for Webpack to say, when you see this particular component, load the local version of it. That's how you enable local development. So we wrote something, it's out there. You could think of it as shared Storybook config. You can install it, you can go look at it. There are some plans for the future, and of course my dark GIFs aren't showing up super well, but a bunch of the things we're working on right now involve using a new feature in Storybook 5 called presets, supporting design docs natively, so MDX if you're familiar with that, also including all of your prop type documentation, and looking to support multiple tools. So one of the really big problems for people that are using DocZ is that the most of the components that they're working with already have stories. So how do you take those stories and make a site out of them? So this is trying to be a glue between multiple tools to make that easier. So you've gone out and you've said, okay, we can hit the presses, we can go and we can publish our package. What could possibly go wrong, of course? So you're out there, you hit the start button, and the problem is that most people don't realize when they're writing these components is that production begins at publish. There are a bunch of things that you can do once you've published the package. You can break your consumers. All of your hopes and your dreams about being reliable, they get squashed. Publishing can break a bunch of things, specifically your npm install and unit tests. So if you have a set of developers, 10 or more, or 50 or more, in our case, 500 or more, and you break their unit tests, they're going to be very cross with you. And so you need to tell them that you're going to expecting to break their unit tests. We had something the other week where we're breaking unit tests intentionally for upgrading to the latest version of React's context API that's shipped in 16.3. There's no way to do that without breaking your unit tests. It doesn't break production, but it did break your unit tests. Plus, there are a bunch of people that might not even be using what you're doing correctly. And so you're going to break their horrible hack that you wish they didn't do, but they did anyway. So there are a bunch of different ways to solve this problem. One of them is to have a really strict build set to try and say, look, these are the things that I want in Node, right? So you're shipping your transpiled code, and then for anything that supports ES imports, right? If you're using Node with the experimental modules flag, you can have the module code in there. And then lastly, because of the way that React Native works, it's also expecting import-based code. So you have to give it its own special version. So, of course, if you have more questions about this, I'll be at the speaker lounge after this. So then you've published your package, and now you want to go and promote it into various environments. Now, who at their work today practices continuous deployment for their product code? Reasonable number of hands. I expected more, but okay. Design systems and continuous deployment are just incredibly difficult, especially the way that we deploy them, which I'll talk about in a minute and why that's important. Because someone could be using something that you've written in a completely incorrect way. They could have hacked it, they could have overridden your CSS, they could have completely ripped inside the component and broken the API contract. But if you're doing this at a production scale, you have to support that risk. You have to just say, okay, well, they're going to go and do that, so therefore there are simply too many unknowns to this process, and we just have to wait. I don't know if this applies to a small scale, but I do know that it applies to a big scale. And how we solve this problem is we just leave things in dev and test for like a day. So we promote into dev and test, and then because we are so essential to what these engineers are doing every day, if there's a break, if we broke their unit test, like we hear about it like that in Slack within 10, 15 minutes. So you've got your component, you've published it, you've rolled it out into your test environment, and now it's time to go roll out into production. So let's go out into production. This, of course, leads to many, many scenarios that end up looking like this. You make a very small change that you don't think is going to have any impact, and then all of a sudden everything has fallen over. So your bundles, meaning the bundles that your consumers create, should not include your design system or your dependencies. To put this in another way, you need to bundle up out there and use a vendor bundle. So there's some app, right, their application, but their application shouldn't include your design system, right? And your design system shouldn't include React. So you have these three different files that get loaded. So you don't have multiple versions of React on the page. You don't have multiple versions of your button on the page. So just a small call out there. We'll talk a little bit more about bundling as we go on. Another way to think about this is that there should really only be one true version of your design system at any time. So what do I mean by that? So you're at your computer, and you're going to publish your design system to something like NPM. And then you have all of your users, and they're going to install any version they want. So these aren't web browsers. These are other servers that have decided to install your package. So that means your users, your consumers, they're all going to get different versions of your design system. And so that means if somebody finds that bug in a dropdown or a button, how are you going to fix it everywhere? You have to wait for all of those people to deploy. And when I explain this to people, they generally feel the way I feel, which is, no, we're just not going to do that. That's just not going to happen. So you have to enforce this consistent delivery, or you're going to face peril. So what does that mean? It means centralized deployment of your design system. And what are those benefits? There are a few. First of all, as I mentioned, you can fix your bugs faster across sites. You can roll back any breaks quickly. You can easily rebrand your system. So one of the things that we tout as a very central value add to what we do at GoDaddy is that if the brand or the company decides that they want to change the look and feel, we can roll that out to every site worldwide in under an hour. And we've done that a few times in my tenure. You also get better insights into your usage, because you'll see who's downloading what version of your design system. You can include instrumentation code to see who's using what, which lets you decide how you want to do bundle splitting. So I'm sure I've piqued your interest. You're very interested in learning more, and how do you do it? I'm glad you asked. First of all, you want to separate out what I was talking about before, right, into those different bundles. And the way to do that is using Webpack Externals. And then you want to expose those in a versioned NPM package. So if you don't know Webpack, maybe, who knows Webpack in the room? Okay, good. How many people really know Webpack, though? Like, do you know what it is, or you know how to, okay, that's what I thought. Nobody really knows Webpack. Most people, when they hear about Webpack, they just make this face. Just no idea. Like, I know it's important, but I don't know how it works. So what are Webpack externals? Let's look at that for a second. So any Webpack bundle is essentially two parts. There is the module loader, the factory. It's a bit of code you'll see at the top of pretty much every Webpack bundle. And then there's an array of modules. Each one of those modules is the code to the actual module. So module 1 code, module 2 code, these are all wrapped in functions. So when you externalize something, you still get that block of code, but instead of it being the real code, it is a path to something that already exists on the window. So the other bundle, previously, like that react.min.js bundle, they're setting window.react. And your design system is setting, window.designsystem.button. And all this is doing is mapping between them. So there's a very specific way to externalize things. This is config that I'll never understand all of it. I think I mostly understand it, but it's supporting AMD, UMD, along with node style require, and the other style of node style require, CommonJS and CommonJS 2. I still don't quite understand the difference between. But it's saying that when you're looking for this component, it encounters the require, go look for this particular thing that's on the window and use that instead. So what does it mean to externalize this? You would ship this in a package, like your system Webpack config, and then anyone that's consuming your system is going to require it and use its externals. So it's this yellow block right here. So now you're versioning your externals, so when you say add a new component to your design system, it's going to automatically get externalized the next time people install things. So now you've got a way to externalize things, but how do you actually get the content out there? How do you make sure that everyone's using the same script and link tags for your design systems? In other words, how do you ensure consistent asset distribution? So you're back at your computer, you're going to publish your design system, and on the other side you have all of your users. And you need them all to have the same version of the file. So you could publish to some kind of intermediary, and then they go out and they request what version they should be including every 10 minutes, 15 minutes. And this is what we do at GoDaddy. Well, there's an open source system that we wrote to do this called Warehouse. And then everyone gets the same version. Because every 15 minutes, every server in your whole company goes out and says, hey, what's the latest version of the design system? What's the file that I should be including on my page? And this is great for a bunch of reasons. But it's also got its downside. Because you want the gold, but you don't want horrible, horrible failure. And there are a bunch of ways that this can fail. So when you're removing externals, that can be really dangerous. When you're renaming externals, you need to sometimes do a little bit of massaging. Ensuring that people are using it correctly, also dangerous, but nothing you can do about that. And of course, there are the unexpected consequences, the places where they're hacking what you're doing, and you have to roll back. You have to do something about it. Like, you've rolled out, there's been an unexpected break, and ideally, you want to go and just, get rid of the entire problem altogether, but you can't. You have to actually have a real rollback plan. So some of the things that we've done in Warehouse to make this easy so that you can be some sort of happy cat at your computer is that it's all based on NPM. So you would just distag the prior version at production. You can try this out. It does require a bit of setup. If you've ever used Cassandra, that's the database that's behind it. But we're working on moving it to DynamoDB, which should make it sort of a lot easier to install sometime towards the end of the year. So now you've got everything out there. You have the first version in production, and you have to maintain things, making sure that fires don't happen, and when they do happen, you don't end up feeling like this. You're there, you're excited, waiting for it, and then everything goes wrong, just all of it, which is, of course, DevOps, when things don't go as planned. So we remember our example here. We have our great setup, but that went down for some reason. And now, all the next requests are going to fail. And now, everyone is down. And the people who hired you are screaming like this at you because you've introduced a single point of failure into the system. And there are ways to mitigate this, but in order to do that, we have to talk about a really scary thing that nobody likes to talk about, which is caching. So there are really two types of caching, and it's really, really important not to conflate them. The first one that most people are familiar with is performance caching, and that is saving copies for speed. So same thing as before. Let's say that the request to get the files is 80 milliseconds. That means if you did this every time, you'd be adding 80 milliseconds to every one of your requests. But when you always use a cached copy, then it's 0 milliseconds. You only pay for that cost the first time. But the more important one, the one that'll solve it for you here, is saving copies for later, which is failover caching. So this content, right, your design system, is highly cacheable. If in the event of downtime somebody's using your design system from 2 weeks ago, it's fine, right? Like, oh God, you have last week's button, like it's fine. So to do that, you want to have some kind of disk caching in place. So you have some unexpected downtime, but when they use the failover cache, which is on disk, it's in their container, they have it, then everybody's still up. It does halt deployments, right? You can't do a new deployment, or if you do a new deployment, you have to make sure that that part of your file system is safe. It's not overwritten on deployments, but you've mitigated the single point of failure. Over the last year, we've had like 9 minutes of downtime in that system. So it needs to be highly reliable in the first place, but you've got to have this other level of ensuring that people cache your responses, because it's okay to use the old version when there's unexpected downtime. This is also referred to as, I forget the word. It'll come to me later. Anyway, so to do this, to do the impossible thing, not really that impossible, but to do that, this is why we created a reusable out-of-band cache. So you're writing any sort of API client, you want to do this out of band, meaning that you go and you get the version of your design system, but then you're going to use the cached version, and then out of band, it's actually going to go and get the next version. You don't want to wait for that cache to expire. You want to refresh it without blocking the user. So this is incredibly simple to use. So this is a very simple example using fetch. So we've set up the max age cache items for 10 minutes, still serve the expired cache for 1 hour, and also disk cache. So we're going to save these responses into a .cache directory on our file system so that if we fail over, we will use those files as the responses. Then we're going to get some URL meaning the URL to your design system. And we're going to use that as the cache key, because that's probably the easiest way to represent it. You could SHA it or hash it in some way. And then we're just going to fetch it. And to do that, we're going to use cross-fetch. And then we're just going to put that JSON, give it back, and throw it to disk. So, getting towards the end here, there are a couple more things to think about. How do you keep your car nice and shiny? Hygiene, i.e. paying technical debt. And I always talk about this towards the end here, because most of the times when I talk to people about tech debt, they look at me and they have this face like, nope, we can avoid it, we can deal with it. Nope, you can't avoid it. On a long enough timeline, it will take down your systems. It'll cripple any software project. Not front end, not back end, just any software project will fall under the weight of its own technical debt if you don't address it regularly. And if that sort of makes you feel like this, like you don't know what I'm talking about, upgrading to new versions of React or Babel. How many people really enjoyed the upgrade to Babel 7? Yeah, I didn't think it was a lot of work. It was necessary, you had to do it, but it was a lot of work. Upgrading to the newest version of Webpack, always pain in the butt, but you got to do it. Removing deprecated APIs. This is the current, I think, tech debt for people that's going to be for React 17 is component will receive props and a couple other ones. Also the latest APIs. So you have a tooltip component that was written before React portals were released, so it's probably better to rewrite it with portals or upgrade everything to the React 16 context. These things, if left unchecked, are really going to have a huge impact on the usability of your design system for your engineers. But if you can handle all that and avoid the pain of this, then you'll be pretty good. And I hope it works out for you. These will all be up on the internet pretty soon. And thanks for listening.
Great. Thanks for great talk. So basically we have like 5 minutes in timing, so probably we can ask 2 questions, and after that you could find Charlie on Speaker's Corner on Beanbags. Do you have somebody questions? Yep.
Hi, thanks for the talk. My question is, how do you ship your styles? You don't bundle them with Webpack,
So we do. We ship a CSS include. So the warehouse response it includes just a set of files. So it'll include like the JS file and the CSS file. So in the Webpack terms, we have 2 different entries. So there's like a Webpack config for the JavaScript and the Webpack config for the CSS. But you could do it a bunch of different ways. Right, yeah, we have a top-level CSS include, and then like an index.css and an index.js, and we don't, like a lot of people import their CSS in the JavaScript, we don't do that.
Hi, Charlie. I'd like to know, I see this change coming in our company now with React moving to the new hook API. And I was wondering how you handled it in your case. Like, do you assign one developer to
Sure.
do it, or do you spread it out to everybody?
So paying technical debt, like if you have a big enough team, you can generally just sort of spread it out. Like the classic example I like to use is that we upgraded very slowly to Flexbox over 18 months because most of our CSS, like with the exception of the grid, the stuff where they were using our classes that were Flexbox based, it was encapsulated. It didn't matter if we were Flexbox or float based. You were just using a button. You were using a drop down. And so we could do that very slowly over time without having to say, okay, we have to stop all product development or all new features and pay the debt. It's like I think of it like a tax. Like every sprint, there's a tax. Like 10%, 15% is technical debt. And if you are really forceful with other managers of your backlog, that you're always doing a little bit of debt pay down, then it'll never crush your team.
One more.
Thanks for the talk. I actually have two-part question. First, do you do any screenshot testing of components when you migrate from one version to another, just to see the visual consistency? And the second is about how do you keep the actual design system consistent, so everybody in the through the whole stakeholders know how to use those.
So
Thank you.
The first part about visual diffing, we don't do that, but that's something we're really interested in doing. We were looking at WebHint for doing that, which is another OpenJS project. And on the second point about making sure people understand the changes, we have some internal DevRels, developer relations people, that when there's a big enough change design-wise, they'll send an email out to a set of stakeholders. We have Slack channels where we say, hey, this change is coming, just so you know, hey, now the change is out. And we've learned over time that it's, let them know that the change is coming, and then when the change goes to dev, then tell them again that the change happened, because that's the day where they'll say, oh, this looks weird, and it's that day, that's the day that they'll go to the Slack channel and say, oh, okay, they just changed it, that's fine, that's intentional. And then you do another notice when you're in prod, but at that point, most of the developers already know that it's coming. They're like, oh, yeah, I know that change. And then they're going to tell the other stakeholders on the team when they finally notice it in prod, like when the engineering manager or the UX person notices it in prod. It's like, oh, that's by design. You can go talk to their designers about it. So, cool. Thanks, everybody.
Yep. So